All right, so this is project 9, and today I'm going to be basically showing the walkthrough of the hardware and then what's changed since project 8. So the main difference here is that instead of transmitting over Wi-Fi, I'm going to be transmitting the roll, pitch, and yaw data over Bluetooth. So to show the setup here, we've got my laptop here, which is going to be the host. And just for ease, for testability, I was having this unmounted from the drone, since I can't even fly it anyway in my DC apartment. And as I moved the IMU around on my Arduino, this was reflected in these values that I'm transmitting to the host here. So to kind of walk through the setup, we've got an Arduino, same as last time, with the IMU attached to the breadboard, the necessary pins connected via these wires for the I2C transmission of the data. On the Arduino, I'm running FreeRTOS with a couple tasks. One to retrieve the data every 100 milliseconds. Again, same setup as project 8. And I basically perform the calculations for roll, pitch, and yaw, and then that gets sent over serial data via this cable to the Raspberry Pi, and the Raspberry Pi running Linux. Previously, I had just remote desktoped in to the Raspberry Pi from my laptop, and that connection was done via Wi-Fi. And then I just had the Arduino IDE pulled up to show the transmission of the serial data here. So the difference here was that I actually had to set up the Bluetooth connection from the Raspberry Pi to my laptop. So to kind of show how that worked, I can actually go up here and show on my laptop. You can actually see this is the name of my Raspberry Pi, so that's clearly connected. And just to kind of show this, I've got an SSH terminal pulled up of my Raspberry Pi, and so if I type in the Bluetooth control service here, I can actually display devices connected. Okay, and you can see here, NIC's MacBook Pro. So I clearly had the Bluetooth connection going on there. And then if I exit out of here, I can show, so essentially what I did was I took the serial connection of the Raspberry Pi that's receiving the data from the Arduino. And if I just kind of list out where that device file is, TTY star. Okay, so there's a whole bunch, but the one I'm looking for is this one. So the TTY ACM0. So that's the serial port that's actually feeding in the data from the Arduino. And I wrote a Linux script to just connect that up to the device file that I have outputting connected to my Bluetooth connection with my MacBook. To show that one, I've got so it is this device RFCOM0, and that's the setup that was described in the example Word doc provided in the project instructions. So I basically am just feeding the data into that serial connection, and then on the output on my MacBook, I'm taking that serial data with this CoolTerm application, and that's what's running here on the bottom of my screen. That's actually receiving that data. So I've got the full end-to-end connection where data is transmitted from the BNO055 device. It's sent to the Arduino, captured, sent via serial to the Raspberry Pi. That's being transmitted via serial connection over Bluetooth to my Mac, and that's being picked up by this CoolTerm application and displaying here. So that's it. Thanks.